So I'm Oriol, and I'm going to present you today high availability features inside BeeGFS. So first of all, I will do a brief introduction to HPCNow, very short, and then we will talk about a bit overview of BeeGFS, and then we'll talk about the BeeGFS high availability features, the classic approach, and the mirroring one, and finally some customer cases. So we as a company have two different backgrounds. There is people that comes more from the IT side, but we have also scientists that have been doing a lot of computing. So we have a mixture of knowledge, and we provide HPC services and solutions. And in fact, I was a client of HPCNow first. And so we are a user-oriented company, so I've been a client also, and I know how I want the thing, so I know how the client wants the things also. And we try to be also hardware agnostic. So that means that we try not to link to any specific vendor so that we can provide the best and cheapest solution for each customer. So as a company, we do consultancy, installation, administration, support, and also training. And we are involved in ETP for HPC, which we become member in the last month. We also are in charge of the HPC Knowledge Portal, which organizes more or less each year a meeting, the HPC Knowledge Meeting. And then as a startup, we were at Barcelona Activa making business with the companies there. And we are also members of the ANEA Industrial, that it's a Catalan network of industrial engineers. So just an image of which are our different customers. I'm not going to talk about all of them, just for you to see. And after the boring part, we can go to the BeeGFS overview. So for those of you that don't know BeeGFS, BeeGFS is a parallel file system like GPFS and Luster. So you have there the set of clients, and here we would have the metadata service. So this stores the information about the files, like file name, attributes, owner, etc. And then we would have the storage service. We are a gold partner of BeeGFS, and although we are also a gold partner of Luster and GPFS, we are going to focus today on BeeGFS. So let's focus on what is the approach of BeeGFS high availability. Just not to have any misunderstood, here we are going to talk about availability, not data loss. So not availability means that I cannot access my data, not that my data has disappeared forever. So that means that my jobs maybe are hold until the storage is back, but they can continue at some point. I might need to do a fix in hardware or either in software, but my data is there. So what means a data loss? A data loss means that I might have to recover from a backup. So that means that some of part of the storage might have been broken, so I will have to recover from backup. I might have to recompute some of the results because the data is no longer there. Imagine a scratch. So if it's broken, maybe you have to recompute your results. And in some cases, the damage might be repairable, and maybe you have lost ages of results. So let's talk about the classic approach of high availability. So if you've worked previously with high availability, you might have heard of Pacemaker. Pacemaker is a layer that manages the resources. And then you would have chorusing, that it's a communication layer to check that the services are okay and send messages between them. So you would use a pacemaker to manage the different BeeGFS services that, as we see in the part below, we have metadata service and storage services. And then the virtual IP addresses. So as the services are linked to an IP, those IPs, in case of failure, need to migrate to another machine. And also the mount points associated with the machine will have to migrate. All this part, would be managed by pacemaker. The chorusing part would be doing the communication along the servers to check that the server is there, etc. Then you'll have to deal with also with Stonith, in case you have not worked previously with high availability in the traditional sense. Stonith means shoot the other node in the head. So that means if you think that the other server have crashed, you send the signal to the other node to reboot. And also to provide these features, BeeGFS provides with a set of high availability scripts to integrate the solution completely. This traditional approach has some advantages and some disadvantages. From the advantages is that no storage capacity extra is needed, but this solution is a bit expensive. As we have seen, we might need as an array, we might need special cards to share with by two paths the same disk, so we might need to use also multipath for this. Also, in that case, we would rely on third-party software, so something that it's not developed by BeeGFS. It would be pacemaker and chorusing. So if there's a bug in pacemaker and chorusing, you will have to deal with another third party. So as I was saying, it's a complex setup to maintain because you have many layers. You have the sun array, you have the pacemaker, you have the multipath, etc. Then there is the risk of failover, as the messaging layer of chorusing is not the same network that is used for the storage. So if the connectivity or the chorusing layer loses connectivity, your storage might be up, but maybe you have a failover because the chorusing network has failed. And we have not increased our data safety. So now we are going to talk more about the mirroring approach, that it's the approach that it's built in BeeGFS. So BeeGFS provides support for metadata and file contents mirroring, and the mirroring capabilities are integrated into the BeeGFS services. In this case, there is also high availability features because it's not only that the data is being replicated, but the service takes over and continues working. So this is since version 6.0. A big warning here. Mirroring doesn't replace backups. So this is just for availability, not for data loss, as I said in the beginning. So let's talk about data replication. So we would define, in this case, body group mirroring. So we have a body A that we define as primary, and then we define another one as secondary. So that means, later on we'll see more specifically, that if we want to write the data, we write it first to the primary, and then we send the data to the secondary. The data is not considered written until the data has been stored in the secondary. As you can see here, the writes can only be done from a single point, but the reads are done from both servers. We can read from both servers. So although we have configured here maybe a body mirror, this does not mean that we can only store there data that we want to have mirrored. We can also store there data that we might not want to have mirrored. Then, as I was saying, the reads are possible from both targets, and we could configure it automatically in this way. So if we have a set of machines and we want to define this body mirror, so in this case we have the group ID 1 and the primary target 1, so that would be the storage 101, and it would be mirrored in the storage 2. And we can make BeeGFS do this automatically for us, or if we want to have a special setup, we can define it also by hand. And well, this will allow us to list the mirror groups that we have. So what will happen if the body mirror group is not available? So imagine that we have a crash in the storage 01. As I said at the beginning, in this case, it's high availability, so we have lost target 101, but we have this here that it's still capable of providing us access to the data, and the same happens here when we lose this server, that we lose access here, but the data is still available from here. So it is important to remark that body mirroring can be enabled globally on the whole file system. So you specify it in the root, but also you can specify on per directory basis. So this can be seen more clear here. So imagine that we have a BeeGFS mount point /mnt BeeGFS, and we might want a folder called mirrored to be mirrored. So any data that we copy there, we want it to be replicated. And then we might want another folder that it's called unmirrored, that the data is not replicated. So when we write a file in the folder mirrored, that would mean that due to the mirrors that we have defined, in this case, the chunk in which the file has been divided would be replicated to the other body mirror. But also, as I mentioned previously, although we have a body group, that means that we can also store a file there, but this file is not going to be replicated. So this is important because what happens is that when you check the free space of your file system, it will show you the total amount of space free. But you have to take into account that when you write something on a mirror directory, it's going to occupy double space. So, which is the advantage and disadvantages of this solution? So, it is flexible, so we can add more servers, more targets, etc. easily without having to duplicate everything. So it's easy to scale and extend. So for example, here we could add in this server more targets. In this case, we do not rely on third-party tools for monitoring and failover, so everything is built in BeeGFS. So if you have a failure, you can report it to BeeGFS, and they will take, if you are paying support, of course, they will have a look to the logs, etc., and get back to you with a solution. So any storage backend can be used. So you are not linked to, if you buy a SAN array, you might be linked or forced to use that vendor forever. And with this solution, you might have here these two cabinets maybe start with vendor A, and these two are vendor B because have a cheaper price. And also you can buy the hard disk to different vendors and get the best price. So in this case, as we see, we have additional data safety because if there's a failure, we might be still capable of accessing the data. And well, there is here, as I was saying, an overhead in storage capacity. So if you are storing something in a duplicated folder, that means, well, in a mirrored folder, that means that the data will occupy the double of a space. And also, due to the having to store the data on the body mirror, you have a write penalty because you have first to write the data on your disk and then send the data to the secondary. So there is a write penalty for the replicated data. So now I want to present some customer cases. So these are real solutions deployed on different customers. So this is from the IPC, Donostia International Physics Center. This is Scratch storage for 172 node cluster. So it's focused totally on performance and low latency. And for this, they have currently about 90 terabytes of data and 0.6 terabytes of metadata. And there are 6 BeeGFS data plus metadata services in ASUS commodity servers in this case with internal disk. This is not mirror, nor data, nor metadata. And it's connected through InfiniBand, and more or less the theoretical performance, it's 4.8 gigabytes per second for reads and 4.4 gigabytes for writes. And the performance in this case can be increased by adding this. So in this case, we are not limited by the network, but by the throughput that the server can give due to the amount of disks. So if we add more disks to the system can provide more throughput. So this is from the ALBA in a synchrotron beams in Catalonia. So these only have metadata mirrored, so metadata operations are always available. So if one of the servers is down, maybe I cannot access to the data, but I still can check if I have a file, although I might not be able to access the file. And well, in this case, it has been built also with ASUS commodity servers with internal disk and two 10 gigabit Ethernet servers. Each server has 10 gigabits in bonding, and then more or less the system can give 1.5 gigabytes per second on reads and 1.2 gigabytes per second on writes. And in this case also the performance can be increased by adding more disk to the system. And well, this is the last customer case that I want to present. This is Renfield, the Spanish railway service. So they wanted a backup storage solution. In this case, we were not providing the backup itself, but the storage that comes with it. So the system has to save has to make backup of with Commvault. Commvault is the backup system of 100 plus servers that are backing up at the same time. So they have two different sites that are separated 10 kilometers between them, and they have 400 terabytes for data and 600 terabytes of data. In this case, we have for BeeGFS with data plus metadata in Dell commodity servers, and in this case, they wanted to have full mirroring. So they have data and metadata mirroring. So that means that the 400 terabytes of net space, as everything is mirrored, it's converted in 200 terabytes. And then for the connectivity, they have 4 10 gigabit Ethernet each server, and the system is designed to survive the complete failure of a full site. So one of the two sites can fall completely, that you will still be able to make the backups. So more or less, this is the network diagram. So that would be site A. and the 4 BeeGFS clients, and this is side B with the body mirrors of the corresponding site A. So at the same time, from the 4 10 gigabits Ethernet that they have, 2 of them are bounded and are used for the Commvault network backup, and the other 2 10 gigabit Ethernets are used for internal BeeGFS communication. So these are 2 separate networks, and it can happen. You might have here or take into account that you have the write penalty in the write. So every write you do in the system, it has to go to the other side and write the data also. So that would be our experience with BeeGFS. If you have any questions, I will be happy to answer them.